Welcome back to AWS DevOps training series. In today's session, we are going to understand more about what is a VPC, what are the major components in VPC, and we are going to see some key concepts, especially what we deal in our DevOps role and all. It's majorly towards Internet Gateway, NAT Gateway, what is a subnet, and some terminologies like what is a peering connection, what is a private link, and direct connect. So we are going to learn some terminologies there, and also we are going to do a very small demo on this VPC, a kind of hands-on, like where you create a VPC, create a couple of subnets, and create a public subnet and a private subnet, and try to launch an instance in public subnet and a private subnet, and try to check how the connections are going towards the internet and how they are called as a private and public. Okay, so to get all this kind of stuff, so first VPC is a kind of core concept in AWS. We generally call that as like what do you say, the heart of Elastic Compute Cloud, or it can be a lot of things are related to your VPC, because this is the core subject in AWS where you need to understand more and more conceptual level, and also more like an understanding on a networking perspective. And this VPC service is very important for people who are aiming for the network engineers, or people who are aiming for a where they want to work into an infrastructure department. So there this VPC plays a major role, but for us it's like where we utilize the VPC for setting up our infrastructure and all. So coming back to VPC, so VPC is called as a virtual private cloud. So in AWS, let me just okay, so let me get here. So in VPC, we call it as a virtual private cloud, and there are multiple features that VPC provides, like subnets, route tables, internet gateway, elastic IP address, security groups and network access control lists, peering connections, VPC endpoints and flow logs, private link and direct connect, and VPC peering. So all this we're going to see and understand what all those. So as we see, VPC stands for a virtual private cloud. So virtual private cloud is a place in AWS infrastructure where you are going to procure to build your applications or to build your infrastructure and all. Okay, so AWS is a huge hardware provider for your applications, for your data centers and all. So in that whole very huge data center, you are going to purchase a piece of it at a certain cost and get some dimensions. Like for example, if you are going to buy a piece of land, you are going to have a dimensions like, hey, I want to in the very big farm like this, I want to purchase a 10 feet by 10 feet land. In the similar fashion, in the whole big data center, you want to purchase a particular infrastructure for your application. So that's why all this comes into picture, comes into the considerations for understanding this particular stuff. Okay, so let's get into detail each and every concept. Okay, so in this we are going to understand more in detail what are subnets, other what do you say, route tables, gateways, elastic IP addresses, security groups, NACLs, peering connections and all. So before we get into the other topics on this VPC, let's quickly understand what this basically VPC is like in a kind of basic understanding. Okay, so let me get here. So on this, let us say for example you are going to purchase a piece of land. Okay, if you are going to purchase a piece of land, what do you see, like what are the dimensions? Okay, what are the dimensions you want to have and all those kinds of stuff we generally see, and like purchase, like what is a length, what is a breadth, and what is the cost of it, kind of stuffs, right? So in the similar fashion, whenever you want to take any infrastructure, okay, so whenever you want to build an infrastructure, the dimensions of it is measured in the form of a CIDR range. Okay, we'll get to this, what is the CIDR range and all. So and each and every CIDR range is mentioned in the form of an IP address. Okay, so we mentioned that in the form of an IP address. So IP address is nothing but it's a place where a machine can communicate, or it's a number at which machine will communicate. Let us say you are using a mobile phone and you will be having a number like 9966, something like that. Okay, so at this particular number, like for example an Alex is a person, so Alex responds to this particular number when we call. In the similar fashion, IP address is where, like for example, if a server is attached to IP address, so this IP address is a place where at which this server communicates. Correct? So this is why we associate an IP address to a particular machine so that we can communicate. Okay, so to address this, for example, let us say if you are launching 2 instances, 3 instances in a particular virtual private cloud, so there should be a limit, right? So what you are how many you are launching and all, so all this comes into like a CID range and all. So we'll just see the description and all in detail, and the IP addresses, like how we set and all. But before that, first try to understand why VPC is so important. What is a VPC? So VPC is nothing but in a very big infrastructure of AWS. So this is like, for example, let us say this is Amazon complete data center worldwide. Okay, data center worldwide. So in this data center, so as we discussed earlier, so this data center is divided into regions, right? Like for example, US North Virginia. Okay, US North Virginia, let us say for example some Australia, Sydney, it's a Sydney region, and Mumbai region. Okay, and something like Ohio region. Okay, and under each and every region, it's again subdivided into availability zones, right? Like AZ1, AZ2, AZ3, something like that, AZ4, availability zone 4, something like that. Okay, based on the availability and all. So whenever you want to create a VPC, so first you need to select in which region you want to create your virtual private cloud, because this virtual private cloud will give you the set of IP addresses where you can attach to your machine. Okay, so virtual private cloud is nothing but you are requesting or you are registering certain amount of IP addresses with Amazon, so that you can utilize that in infrastructure not only for launching instances but for setting up many other infrastructure items which communicate on the basis of IP address. So that's why we need VPC, where there are many services which operate under VPC, like databases, it can be web servers, some kind of API gateways, some load balancers, auto-scaling groups. All those stuff are backed by a VPC. So you need a virtual private cloud, a custom virtual private cloud created for you. Okay, so to do this, like once you select a region, let us say for example you have selected a region in North Virginia region, I want to create a VPC, so where all my servers will be in North Virginia region across multiple availability zones. So in each and every availability zones you can create multiple subnets. Okay, so you can create multiple subnets under each and every availability zone. So division of this VPC into a region, like selecting a region and creating a subnets under this, is nothing but creating a VPC. Okay, in a VPC is nothing but you will be selecting a region. In region you will be setting up some range, a CIDR range. Okay, so CIDR range, you will be setting up some IP addresses, and you will be creating multiple subnets for that, where you will be dividing your space more. Like for example, once you have created your VPC, okay, once you have created your VPC, so this is your very big VPC that you are launched in North Virginia region. Okay, Virginia region, and you want to divide that more. So what you'll do, you generally create that into subnet 1, subnet 2, subnet 3, and subnet 4, and these subnets can be launched in different availability zones, like availability zone 1, even in availability zone 2, and in the same availability zone also you can launch another subnet as well. Okay, so like this, so you can create a VPC, and under VPC you can divide your infrastructure into multiple subnets, so that you can accommodate different kinds of requests. You can decouple your applications based on that, and you can launch your subnets into multiple availability zones as well. Okay, so these are the basic concept, like under VPC, why we call as a subnet, and this subnet is launched in an availability zone and all. Okay, now let's get back to this stuff. So this is what we are speaking about subnets, and when we are getting about route tables, so route tables are nothing but, let us say this is your subnet 1. Okay, so route tables act as a, what do you say, a kind of rule on your subnet to mention how is your traffic moving. Okay, so like for example, whether you should want an internet connection or not, who will be able to accessing your subnet. Okay, it's kind of a more like an higher level traffic flow routing. So it's nothing but a route table. It's nothing but you're defining how your traffic goes. We'll see this in detail on the AWS console, but route table is nothing but it defines how a route or a traffic goes on your subnet, how an incoming traffic goes, how an outgoing traffic goes. All this stuff will be described in a route table. Okay, and when you get into an internet gateway or NAT gateway, so this internet gateway or NAT gateway are responsible for having the IP addresses. I want to say the internet connection between your public and the private subnets. We will see in detail why we call it as a public subnet and why we call it as a private subnet. And elastic IP address we have already discussed. Security groups we have already discussed in EC2. It's the same thing. It will be ensuring the relevant ports or opened and all. So network control access lists are nothing but, as we see, security groups are on the instance level. So network access control lists are on the subnet level. So how you allowed the traffic on security groups, in the similar fashion you can allow and deny traffic on the subnet using this NACLs. So VPC peering connections are nothing but whenever you want to communicate between two different VPCs. Like for example, if you have created two different VPCs, so this will be utilized for such scenarios. Okay, for such scenarios this will be utilized to make a communication between two different VPCs. And VPC endpoints and VPC flow logs, we are going to see that. So let's get into the stuff. So as we discussed, subnet consists of the CIDR range, which is nothing but classless interdomain routing, is nothing but a IP address setup. Okay, so if you generally see in your bachelor's or in your education, you used to see this set of IP addresses, but not with /16 or something, but you used to see this IP addresses whenever you are like into a kind of learning areas or wherever you used to see this IP address, right? So IP address is nothing but where this just a second, let me get another color. Okay, so where a machine communicates on this. Okay, so if you see here, these are the set of public IP addresses and these are set of allowed private IP address. So whenever you are going to create your what do you say, a VPC, you need to select this private IP address set, because these public IP addresses are reserved for making a communication on internet. So you should not select this set of IP address range when you are selecting creating a virtual private cloud. Okay, you need to select this set of private IP addresses. So this route tables we have already discussed. So a network access control list, so nothing but it's the set of security you are putting on a subnet to ensure what traffic should come in and what traffic should go out. So as we've seen, so under region, we are going to, under different availability zones, we are going to launch our subnets. If you see this, so there here we have launched 3 subnets. You can see there are 3 different subnets in 3 different availability zone under the same VPC, but under a region. Under a region, you have created a VPC. Under different availability zones, you have created different different subnets. But if you see, there is an internet gateway attached to only particular this subnet, so that instances on this are called as public, instances in this are called as private, because there is no internet gateway attached. So this cannot access internet. Here also this cannot access internet. Only this instances can access internet, but this communication will be present always. But to the external internet, only this subnet can have. So that's, we call it as an internet gateway, where it allows the instances to connect to internet or communicate to internet to download some things and all. But there can be places where these instances should also communicate to internet for downloading some patch management or downloading some kind of data from internet for making your application or updating your application. So that is, we're going to utilize a service called NAT gateway, which is network address translators. So we are going to see that in action, why we need NAT gateways and what is that all. Okay, but just understand a subnet. In subnet we are going to have a kind of IP address range where whenever you are creating, we need to select that set of IP address range to accommodate your what do you say, the VPCs. A VPC will be subdivided into subnets, so that's how you need to select. Okay, so before getting into this, so let me give you some brief introduction about what is this CIDR range and why we call it as that, class interdomain routing, and how this IP address and subnet masks are there. Okay. Okay, so let me get into a simple example for explaining a CIDR range. So here we are going to create a subnet with a 10.0.0/16. So whenever you first say this kind of information, you will be a little bit confused, like what is this 10.0.0/16 and how you should give it and all. So as we seen in the previous slide, this is how this or the different private IP addresses range that you can select, from which based on your usage you can set your number of IP addresses. Okay, so let us take this example of 10.0.0/16. How many host addresses that will be available, and why actually we give this subnet mask, and what does this all says about. Okay, so let's come here. So whenever you want to launch a particular VPC, okay, so you need to have how many IP addresses do we need? This should be your question, right? So like for example, if you launch a VPC, do you need 10 IP addresses, 15 IP addresses, or 100, something like that. So that's where it says, like for example, if you write, let us say this 10.0.0.0 is an IP address which refers to a machine, correct? So on this 10 is nothing but an octet. Okay, so all the 4 digits will be represented with 4 octets, which is nothing but 2 power 8, 2 power 8, 2 power 8, and 2 power 8. So altogether it's 2 power 32, which is nothing but, here it is 255 numbers from 0 to 255. If you 2 power 8 is nothing but 256, so the available values for the first octet is 0 to 255. In the similar fashion, this will be 0 to 255, and this is also 0 to 255, this is also 0 to 255. Okay, so this is nothing but a notation, so don't get confused like why we are only taking 0 to 255, why we are not taking for 2 power 9 and all, because this is something which is standardized from internet protocol, which is nothing but IP. So this is the protocol that we need to follow, because which is nothing but 8 binary digits, it for 1 byte. So in the first byte of data there will be 8 bits, which is nothing but, like for example, 4 zeros, 1 1 1 1. So like this the address goes. Like for example, if you go for 10, so let's convert to 10. 2 5s are 10, so it's a 0. 2 2s are 4, it's a 1. 2 1s are 2, it's 0. So 1 0 1 0 1 2 3 4, and let's add another 4. So it's nothing but the 10 is converted into a binary. Okay, decimal is converted into a binary. So this is how underlying the machines and underlying machines, how they communicate. So this 10 will be converted into a what do you say, into a binary digit format, which is 2 power 8 format, and that's how it communicates. Okay, so this is how this 2 power 8 will be, and this another 2 power 8. So all the IP addresses ranges from, like for example, 0.0.0 to 255.255.255.255. This is the full set of IPv4 range. Sorry, let me erase this. So this is a full set of IPv4 range, Internet Protocol version 4 range. Okay, so if you see in the previous slide, if you see all these IP addresses like 10, 172, 192 or 1.0.0, so this all are like, some come into a public IP address, some fits into a private IP address. So these are the full length of IP addresses which are under IPv4. Okay, so whenever we come into like, now let's see like 10.0.0.0/16. Okay, what does this speak about? Okay, so whenever we get such things like that, so whenever we give this 10.0.0/16, we are saying to AWS that first 16 bits please block first 16 bits like 2 power 8 and 2 power 8. So first 16 bits, make it as constant like 10.0. Make it as constant and please vary remaining like from 0.0 to 255.255, which is nothing but 2 power 8 and 2 power 8. So my available IP addresses now will be equals to 2 power 16. Or general calculation, how people will do is, it's always 2 power 32, right? So this is 2 power 32 always. So this is 2 power 32. So they will directly subtract this from here, which is nothing but subtracting from here, or whatever we get it from here. So you are saying AWS that first 16 blocks, first 16 bits, I mean to say first 16 bits will be blocked, will not change, and remaining bits will change, so that I can get 2 power 16 IP addresses. Okay, which is nothing but, if you see here, 256, if you see here, which is nothing but 65536 IP addresses, which you will get 65,536 IP addresses, you generally get it. Okay, and 2 IP addresses will be reserved for AWS for their broadcasting and protocol purposes, but out of this you will be getting around 655,534. My bad. So it's 65534. 65,534 instances can be launched if you set this particular VPC. Okay, so if you see here, the same thing. If you come here, the first 2 octets are fixed, and next 2 range from 0.0 to 255.255. So your IP address ranges from 10.0.0 to 10.0.255.255. You are saying simple thing to Amazon, hey, I want to have my VPC launched. This is my range. Okay, this is my range, like what we discussed, like CIDR range, classless interdomain routing range. So this is my range in which my IP address range should be. 16 says that, okay, you block the first 16 bits and remaining is 2 power 32 minus 16, which is nothing but 2 power 16. So it ranges from 65,536 available IP addresses should be there, so that my infrastructure should be capable of launching 65,536 instances. But 2 will be the network address and the broadcast address, which will be utilized from Amazon for all your VPC kind of maintenance and all. Rest all 65,534 IP addresses will be available for your VPC to launch your instances. So this says that whenever you see like, okay, so this is my IP address range, this says that, okay, I can launch this many number of instances in this VPC. You cannot launch more than this. You will be ran out of your IP address range, or you will be ran out of your VPC. You need to increase your size. This is what generally we get in a CIDR ranges. This is how you need to come across. Like for example, if someone says and asks, hey, please set up a VPC for me where I can accommodate around like 65,000 hosts, this is what you need to answer. Okay, so I'll be giving an assignment on this basically to, it's an example of 65,000, but once you get into the GitHub repo where you can see an issue or a assignment on this, where I'll be asking for 24, 30 or 32. So if you have a doubt on this, you can just get back, but this is very much important to understand what is the subnet mask. Always think this is nothing but the number of digits where you want to block it. So I'm just repeating this again and again because this is where you need to have your key understanding. These are the number of bits you are getting blocked. So 2 power 16 2 power 32 minus 16 is the available, which is nothing but 2 power 16. So that's why you can see 0.02 255.255. Okay, so that subnet mask is nothing but /16, and for first two octets are fixed, and again it's 0.02 255.255. Okay, so this is how we generally configure a subnet mask, or this is how generally we see how the CIDR range has been calculated. Because whenever you go ahead and create a VPC, the first thing it asks for a CIDR range. So that's why I've explained this in detail. It might be a bit long, but you need to understand this is very carefully so that you can understand the whole network and whole VPC very much clearly. Okay. Some more important topics on this default VPCs or non-default or custom VPC. So this default VPCs, or like whenever you create your AWS instance, your default VPC will be created, and non-default or custom VPCs are the ones you just create. But there is a difference between the default VPC and non-default VPC. So you can directly utilize your default VPC, but there will be not much customizations you can make on the default VPC. Like if you see, the default VPC has been created when your AWS account has created, but whereas your non-default or custom VPCs, you just create based on your usage and you design it or customize it based on your need. Okay, and there are some the subnets for this default VPC are created automatically, but you can enhance by creating some more subnets, but you cannot do much more customizations as we do in a custom VPC that you create. And internet connectivity. So in a default VPC, all the internet gateway route table configurations are present by default. But whenever you create a new VPC, launch a new VPC, you need to configure your route tables. You need to configure your internet gateways and NAT gateways, which we are going to see now. So that's all configurations you need to make it manually, that are not automatically given when you create a new VPC, that you need to have it. Okay, and DHCP option sets, it's not pretty much for R, so we can just skip for this because it's not related to what do you say, a DevOps set of action items. It's more for a networking level. And for route table associations, we generally deal with this route table associations. In the default VPC, whenever the VPC has been created, a route table will be created by default. But for non-default VPC, as we discussed, we need to create the default, I mean to say, a route table for your private subnet, public subnet. If you launch any other subnets based on your subnet usage and all, you need to create all this. Okay, and coming back to your VPC peering and transit gateways. So this supports, in defaults it supports VPC peering, but if you want to customize your requester and your acceptors and anything in the default VPC, that is not possible, which is created by the AWS when launching an instance. But more customizations are possible when you go for a custom VPC or a new VPC has been created. Okay, so this is one small basic difference between the default VPC that you get on an AWS account once it got created, and the one which you create by using a create VPC option or a custom VPC. Okay, so next, one more important topic that you need to understand is the difference between the security groups and NACLs. These are most important interview question that you get the very first item when you attend any of the AWS or DevOps positions across the globe. So first thing is you need to understand the basic thing is security groups are at instance level and NACLs are at the subnet level. So visualize in such a way that whenever you want to provide a security for an instance, the first thing you need to secure is security group, because that is the immediate firewall that you have on the instance. So there is an additional security that you can make on a subnet level using this network access control list. Okay, so this security groups are like a stateful, like it's like a related traffic allowed based on the outbound rules and inbound rules, but network access control lists are evaluated independently. So that's we call it as a stateful and the stateless. So in security groups, by default, inbound traffic is completely denied. Okay, you need to allow the inbound traffic so that you can enter into it. By default, everything is denied. Okay, where the outbound traffic is completely allowed. In security groups, whenever you create a default security group, it comes like inbound is completely denied, outbound is completely allowed. Like in that speaks like if you add a security group to an instance, by default all ports to incoming traffic, like who want to access that instance, will be blocked, and instance can access the internet. This is how the security groups are defined. But whenever you get into the network access control list, it's a quite different, where all inbound and traffic rules are completely denied by default. The only thing you need to do is like you need to enable those inbound and outbound traffic based on your use case. Okay, the rule evaluation is like based on the allow rules. First match wins on this security group. Like for example, there are 10 different rules allowed on this. The very first rule that you get will always be win on that. And the network access control list, so it will be in an order. Okay, so rules are evaluated like first rule when it is allow or deny applies. Okay, like for example, there are 4 different rules. The first rule, which is there, you are coming from an internet with certain amount of IP address or CIDR range, so whatever the rule that for that particular CIDR range is present, it applies. And you can see like there are maximum of 60 inbound and 60 outbound for security groups, and 20 inbound and 20 outbound for NACL rules. Peering, so it's defined itself like VPC peering is nothing but setting up a connection between 2 different VPCs. If you see here, there is a VPC A and VPC B, so you can set up a VPC peering connection between 2 different VPCs, so that it can communicate, the subnets can communicate between each other. Like if there are like instances in this VPC, if you want to communicate with a different set of other VPC, then you need to set up a VPC peering connection. So this is available on the console. You can just get into and set up a VPC peering connection so that both the VPCs can communicate each other. There's other one option called as VPC private link. So let us say for example, in a VPC you launched an EC2 instance, and if EC2 instance wants to communicate to an S3 bucket, so it usually communicates via internet using the REST APIs of AWS. It's communicate via the internet. But AWS private link provides you a dedicated, I would say, a completely private network from your VPC to your Amazon Web Services or to other VPC or some third-party VPC. Like for example, there is an EC2 instance in which your application is accessing a bucket on S3. So then actually what it does is it's get into the internet and browse for s3.amazon.com, and it goes via the internet. But when you set up this private link, it utilizes a concept of VPC endpoint, wherein you will create an endpoint for S3. Like for example, there is an instance present here. If instance wants to connect to this S3 bucket, so this private link creates an endpoint on this VPC stating that whenever someone or some application inside this VPC wants to connect to in-house S3 service, which is nothing but AWS S3 service, don't use the external internet, rather use this endpoint to securely communicate within privately using the AWS network to Amazon S3 bypassing the internet connection. So this is what private link is used for financial, let us say for financial applications or banking applications. If they don't want to use the internet for their communication of data or data transfers and all, so they can set up this private link to securely transfer the data or securely communicate between multiple AWS services with the services which are launched inside the VPC using private link. So there's another one called as AWS Direct Connect. So this AWS Direct Connect is nothing but when now currently, let us say now you're logging into AWS console using AWS infra, I mean to say the internet, and using a management console you are connecting to your AWS infrastructure. But AWS Direct Connect is an option where let us say this is your AWS cloud and this is your network. Okay, let us say this is your office in which there is a client machine and there are servers. If you want to connect to an AWS AWS cloud without any external internet, so direct connect is an option where you can set up this direct connection. You can get in touch with AWS to set up this direct connect. So they will be providing you the detailed structure and detailed the infrastructure required to a dedicated set of connection from your customer gateway or nothing but from your customer network. So I'm speaking with respect to Amazon, your customer. So that's why the documentation says that customer network is nothing but it's you, from which you can, using that customer gateway, you can directly connect to the virtual private gateway of your VPC and communicate with multiple services present under that VPC using this direct connect. So this will also bypass the internet and directly connect between the servers or services present in your VPC and from to your customer network. So that's all on the major concepts that we see on VPC. So let's have some particular demo on VPC where we are trying to create a custom VPC with some subnets and add some route tables, set up some internet gateway and NAT gateway, and just do a simple implementation on that. So this is the similar use case where we'll be creating couple of subnets like a public subnet and a private subnet. And a public subnet will be having an access to an internet gateway, but private subnet, the instances in private subnet will not be having a direct access to internet, that we'll see. And we will be setting up a NAT gateway like this inside a public subnet so that it can access the internet. If you see, private subnet is able to access the internet, but using this NAT gateway, but without this NAT gateway, private subnet is not having any connection to internet. But public subnet is directly attached to internet gateway so that it can connect to internet directly. It can communicate to internet, and these are visible. These are visible across the internet. But whenever you get into private subnet, it is attached to the network gateway, and on the internet, this is not visible. This private subnet is not visible. So that's why we are calling it as private with respect to internet. This is public with respect to internet. Okay, so let's get into some hands-on and see like how this VPC and all, like just create a simple custom VPC and set up all the stuff. I've logged into my VPC AWS management console. So in the search bar you can start typing VPC. You can get it here under services. Just click on VPC. Now we are going to create a custom VPC with a similar CIDR range what we have seen in the example. So go into your VPCs, where you'll be having an option to create a custom VPC under a region. So here I'm selecting the North Virginia as a region for creating all my infrastructure. So I'll hit create VPC. So I'll do a VPC only. There are much more options like VPC and more, but it will be a bit complicated when we try to implement as a first stage. But we can do a VPC only. So I'm giving like my demo VPC. So I'll keep that IPv4 CIDR manual input. So let me mention as 10.0.0.0/16 is my IPv4 CIDR range. So I don't want any IPv6, so we are not much interested in the version 6 protocol. We are only interested in IPv4. And tenancy default, let's keep it as is, and let's go ahead and create my VPC. So it says that you successfully created the VPC, my demo VPC. You can click on your VPCs and you can see your VPC is available. Let me check this. So it's my demo VPC and my VPC is available over here with the CIDR range. If you scroll towards right, you can see there is information about like what is the CIDR range, IP address v4 10.0.0/16 and status is associated. So your VPC has been created. Now next thing is you need to create the subnets. As we discussed, we are going to create couple of subnets. So just hit on create subnet. So I'm just clicking on under my demo VPC. I'll be creating two subnets. So first subnet is my public subnet. Okay, and availability zone, let me select as 1A, and for this I'll be dividing that into 2 power 16 into 2 power 8 and 2 power 8. So 2 power 8 is nothing but 2 power 32 minus 8 is nothing but 24. We need to block so that I can get 2 power 8. So 10.0 slash I'll give it as 24. You understood, right? So it's a 2 power 16 we want, so 2 power 8 and 2 power 8. So subnet mask I'll be using a 624, which is nothing but 32 minus 8. So now this is one of the CIDR block I'll be using. and then I'll just go ahead and create subnet. So my first subnet has been created. You can see my public subnet. So let me do a new one on this my VPC demo. It's my private subnet. Okay, so here I'll be giving 10.0.1.0/24. Okay, so then because it will be the next available set of IP addresses. Let me hit on create subnet. So now you can see I've created two subnets. You can get into subnets like this. Just clear this. You can see there are two subnets created, which are my public subnet and my private subnet. Okay, these are two subnets which I've created. You can see it is under my VPC, and you can see the CIDR range 10.0.0/24 and 10.0.1.0/24. If you can see, there are available IP addresses 251, and here also the available IP address are 251. 2.8 have created, 2.8 have created. You can see five IP addresses will be reserved with AWS for their address allocations and their internal usage. So there will be 251 IP addresses available for us in one of the list availabilities on 1A like this. Okay, so you can see there is one route table got created. A main route table got created for your subnets. Whenever you create a subnet, so there will be a default route table that will be associated, and there is an access control list also that got created. Okay, so these are some informations for this. So let me get into the route table. If you see, there is a route table got created, but this has not been updated with an internet connection or NAT gateway, something like that, for public subnet. And there is a network access control list. If you see, by default it has all allow and all deny. Okay, so this gives you an outbound also, it gives all allow and all deny. So rule number 100 comes into priority, so it says allow and allow. Okay, so now let me get into the internet gateways, or let me get into the route tables as the first one. So let me create a couple of route tables for your public subnet and private subnet. My public subnet RT. Okay, so I'll be selecting the VPC as my demo VPC, and let me create it. I'm not adding any rules right now, I'm just creating it. Later I'll be adding. Okay, so then I'll be creating another my private subnet route tip. You can select the demo VPC and click create route table. Now you will be able to see two route tables, which is my public subnet route table and my private subnet route table. So this my public subnet route table should be associated with the public subnet, and my private subnet route table should be associated with the private subnet. So next, let me create the internet gateway. So this is the internet gateway that got created by default when the account got created, but let me create a new one for testing purpose. Let me say as my demo internet gateway. I'm just creating that. Okay, so I have my internet gateway got created, but it did not attach to the VPC. Let me attach it. So attach to VPC. So I'll be selecting my VPC and attach internet gateway. So if you can see, my internet gateway has been attached to this. So once the internet gateway is attached, my next task should be I need to update my route tables. First, let me check the public subnet. Click on the route table. First, make your route. In the edit routes, they add a destination where I want the internet, all the IP addresses across internet should connect to my internet gateway, my demo IGW, so that this has the connectivity to internet. So this is how you need to add destination as an across internet, and target is internet gateway, so that it will allow traffic from the external internet to connect to this. And next, you need to add a subnet. Whenever you create a route table, you need to ensure like you are adding the subnet under your subnet associations. Click on edit subnet association and select my public subnet. So this is how you are making your subnet as public. Based on the route, you are making your subnet as public. It's not meant by the naming that you are giving, but it's meant by the route what you are making. If you are having the internet gateway inside your route, it's nothing but your subnet is public. Now let me go to the private subnet, and in the private subnet I did not add any internet gateway, so I should not be able to connect to the internet. So for this testing purpose, so let's get into EC2 and launch couple of instances in this. So I'm getting into EC2, instances and public and private subnets. Click on launch instances. So once you land in a page of launching an instance, you can provide the information of like my public server, or you can say my public instance. Let's select Amazon Linux and it can be default. I'll take this as default, and I like to create a new key pair with VPC demo testing, something like that, and just create a key pair. Okay, in the network settings you need to edit it from default to a custom VPC and select my public subnet and auto assign public IP to enable. So you can create a security group with inbound rules and with the TCP/22. Also just add an security group rule for HTTP as well, just in case if you are testing it. So the source should be from the internet. I'm adding this. Rest all should be fine. So let's go ahead and launch the instance. See if we get any errors. So it's creating security group rules. Let's click on details. It should be very fast for us. Okay, so it's successfully launched the instance. You can click on this. You can see one in the pending state, but it will come very fast. If you click on this, you can see, if you can go to the networking, you can see under which subnet this has been launched. So this is under my public subnet. Okay, so now let me go to the instances and launch a new instance. Click on launch new instance, but here I'll be launching the instance in the private subnet so that I can test whether I am able to connect to internet or not in the private subnet. So my private instance. So I'll be selecting the same operating system. So then this also I'll keep it as default. Let me select the same key which I have created just now. Click on edit, select the my demo VPC, and let it be my private subnet because I want to launch the instance on private subnet to check the internet connectivity is there or not. So auto assign public IP should be disabled because we don't want the instances in private subnet to have the public IP addresses for having what do you say the address for it. So we'll keep it as disabled and create the security group. So let's add the same inbound rule as default and just add another inbound rule for HTTP just in case if we are checking any internet connectivity. Okay, so rest all keep it as default and let's go ahead and click on launch instance. Okay, so now your instance has been launched. So if you see my public instance is already created, let's connect to this instance. Let's connect to this instance using EC2 instance connect. Let's click on connect and see if you are able to connect to this or not using the instance connect. Also, if you can just quickly verify this instance, you can see under the details pane you have the public IP address associated because this is in a public subnet and we have enabled that auto assign public IP so that it can communicate from the external internet. But if you get to the private IP address, you don't have the public IP address over here. So now the question is how you are going to communicate here. So here the concept comes of SSH communication. So let's see how we can communicate to this private instance. But before that, let's verify on the EC2 server, are we able to connect to internet or not. I'm just switching to root. So let me ping google.com. Okay, so it's giving me the response. So I can confirm that, okay, I have received 4 packets transmitted and 4 received. So I have a internet connection from 10.0.0.217, which is nothing but my public instance. Which is nothing but my public instance 10.0.0.217. So 10.0.0.217. It is confirmed. Now let me get into my private instance. Let me try to connect here. So if you try to connect here, so EC2 instance will not connect because this does not have a public IP address, and even session managers and all won't connect because you cannot connect using the private IP address from your local machine because this is not public IP. So the thing what you need to do is first get into this and create a PEM file like touch what do you see, let us say for example keydemo.pem. Okay, now whatever you have downloaded, so let me open that file. So if you open that file, I have logged into my terminal. You can use your file explorer if you are on Windows. The only thing is we need to get the content from this particular PEM file. So let me do a cat PEM. I'm sorry, so control C, do a cat VPC underscore demo PEM. So let me copy this particular content which is present over here like this. Copy the content. Let's see, echo. Let me paste it here. Okay. Echo into. I want to copy it to keydemo.pem. Okay. So using this, I can connect to my what do you say, the private IP. I mean to say the private instance. Let us check without that are we able to connect to this or not. So this is my IP, right? So let me check SSH EC2 user EC2 hyphen user the rate. I'm just giving the private IP of the private instance. Okay, 117, press enter. Let me type yes over here. You can see that it's a permission denied. Okay, you can see it's a permission denied. So what you need to do is you need to pass in the information of the PEM key SSH hyphen I keepem.demo EC2 hyphen user at the rate your private IP address. Okay, so then you will be able to connect to this particular instance. If you see, I have logged into the EC2 user of 217. Okay, but if you see it's not connected to 217, I'm sorry, because there is a permission denied error due to the bad permissions on this key. So for this you need to do chmod 400 and key. So this will change the permissions to a right, and hopefully this should get into your 117 server. If you see, yes, now I got into 117 from 217 without having the public IP address. With the key I was able to log in from public server to a private server, which is nothing but a public instance to a private instance. Now let me check in this, are we able to ping google.com or not. If you see, we are not able to pick google.com because it's not able to connect to the internet. You can see 0 received, 100% packet loss. This is because whenever you get into this my private subnet, there is no route associated with this to the internet. So in order to achieve this, we have a concept of NAT gateway, where you need to create your NAT gateway. Click on create NAT gateway. Let me keep it as my demo NAT. Let me keep it as NWG NAT gateway. And we should always launch your NAT gateway in the public subnet. So I'm selecting my public subnet, connectivity type is public, allocate elastic IP. So it will allocate an elastic IP. That's all. You can just hit on create NAT gateway. Once you click on create NAT gateway, let's go over here and just check whether it's available or not. So it's in a pending state, so it will take a couple of minutes for getting that to available. Okay, so it took me like about 5 minutes for getting my NAT gateway to get into a available state. So once this is available, you need to get into route table and you need to update the route table of the private subnet with the routes. Like we need to edit the routes, and in the edit route from the internet you need to attach it to the NAT gateway. So once you select that, you will have an option of this, and now you can save the changes and just check whether your route has been successfully associated or not. Okay, it has been associated and it's active. So what our assumption is, from this 117 server or 217 server, it should get connected. I think it's logged out of that, so let me connect to this again. Okay, so let me check. It's 117 server, so the private instance IP address is 117. So I'm still on this 117 server. So now let me ping google.com. So if you see, still I can't able to connect to this. Let me check why it is. Because I did not associate any subnet for my private subnet route table. Okay, you can see in the subnet associations I did not associate any subnet for this route table. So let's edit subnet associations and put my private subnet and save associations. So now I will be able to see, okay, there is one subnet associated which is my private subnet to my private subnet route table. So let's get into this, just check with ping google.com. So now I can see from 117 private server I am able to connect to the internet. Now let's try another thing, like let me delete this route again and just check, verify whether my private subnet is having the internet connection without the route table or not. So I'm just removing my this, just save the changes. If you see, subnet associated is this for my private subnet, and another routes I'm not having internet gateway. Now if you can come here and just do a ping google.com, it's not going because NAT gateway is not attached. So let's quickly go ahead and do that again. Edit routes, do it again, just in the NAT gateway, select this and save the changes. So now you can confirm that, okay, my internet connectivity to the private instance is done via the NAT gateway. Okay, so this is how generally the NAT gateways and VPC private public subnet works. But there are many other options, like if you can see network access control list, you can see here, and you can just skim through the particular VPC section. But more towards the AWS DevOps training, we'll be much interested in the options of what we have discussed till now. Rest all should be fine for the AWS DevOps training, because we don't much deal any of that particular services in our day-to-day activities, but they should be okay. But please ensure like you delete all the stuff. So